Alrighty, welcome back to maths. Today we're looking at, this is cool, it's the standardization of values and also looking at what's called the 68, 95, 99.7% rule. Oh, cool, that's an interesting name for a rule. Um, you'll find out why it's called that in a moment. So what we need to have a chat about is obviously with normal distribution is looking at what percentage of values fit within certain standard deviations of the mean. And so hence the name of this rule, the 68, the 95 and the 99.7% rule, is as follows. It says that 68% of the values, when we're talking about normal distributed random variables, lie within one standard deviation of the mean. So here again you've got your normal distribution. You've got the mean in the middle here. You can see one standard deviation either side of that. 68% of the data lies within there. Cool. Check. Next is the 95%. And it says 95% of the values lie within two standard deviations of the mean. So again, two standard deviations above, 1, 2, and two standard deviations below, 1, 2. You can see here 95% of the data lies within there. No surprise here, 99.7%, hence the name of the rule, is where three standard deviations of the data, or data lies within three standard deviations. So here you can see three standard deviations both sides. You've got 99.7% of the data. Perfect. That's what that's all talking about. Now, building upon that, there's some other things that you should consider. If we think about one standard deviation either side of the mean here being 68%, then what it means is that if you were to split that down the middle here, you would have 34% one standard deviation above the mean, and you would have the other 34% one standard deviation below that mean. That makes sense because obviously they add up to being the 68. Bringing it further as well, again, if you think about the 95% rule, if we draw back on the 68% here, whoops, imagine that was the 68% from above, then you can work out what value or percentage lies between negative or between one standard deviation, two standard deviations below and above. Now, again, obviously that's 13.5% there. The 13.5% on either side there gives you the 27% more than the 68%. That gives you the 95%. Yep. Now, another way of thinking of it as well is with the following graphic. So let's have a look here. This here shows how you could break down each of those rules. So starting off with just the 68, the 95%, and the 99.7% rule, you can actually take it even further and get each of these values here between each of them. And that's just by using a little bit of thinking around that. Now, it goes on to say, obviously, if you know that a random variable is approximately normally distributed, and you know what the mean is and you know what the standard deviation is, then you can use this rule to make some quick important statements about the way in which the data values are distributed. Perfect. So let's have a look at an example here. This is example 2. It says experience has shown that the scores obtained on a commonly used IQ test can be assumed to be normally distributed with a mean of 100 and a standard deviation of 15. As soon as you see the word normally distributed, we're thinking bell curve, we can start using the 68, the 95, and the 99.7% rule. So what you would do is, and this is how I would go about it, in the middle, at the mean, I would write what the mean is. We've got 100. We'd pop that on there. Cool. we know that a standard deviation in this particular case is 15. Yep. So from the mean, one standard deviation is going to be 15 more. So 15 more than 100 gives you the 115. Likewise, you can work out one standard deviation below the 100. You're taking away the 15, gives you the 85. And it's quite easy, again, to label each of these standard deviations. So not only one standard deviation, but two standard deviations. So two lots of 15 more than that, which you can see, and you're going up by 15s here. Likewise, it's easy enough to fill in these values down this way by going down one standard deviation each time, going down by 15. By labeling these on here with the mean and also the standard deviations, you can then answer these types of questions around the 68%, the 95%, the 99.7%. So with this, because we've said 68% of the scores lie within one standard deviation from the mean, whoop, actually that's a straight line. One standard deviation either side is 68%. In this case, you can see it's the 85%, scores between 85 and 115. 68% of the scores are going to lie in between that. Likewise, when we're talking about 95%, we know 95% is two standard deviations from the mean. Because we've labelled these on here, we can see that two standard deviations below the mean is 70, two standard deviations above is 130. Last but not least, 99.7% of the scores lie within three standard deviations. Three standard deviations we wrote on there was between 55, and three standard deviations above is between 145. So that's pretty awesome to be able to do that. Next thing that you need to know is that statements can also be made about the percentage of scores that lie in the tail areas of the distribution. And that's by using the symmetry of the distribution, noting that the total area under the curve is 100%. So as we said over here, you've got the 68%, the 95%, the 99.7% rule. If we think about the tail bit after the end here, after the 99.7% rule, there's still that 0.3%, which means that there has to be 0.15 and 0.15 over here to make that 0.3% at the end. Yep. So that's useful to know as well. Alrighty. Okay, this says, for example, number 2, we knew that 95% of the scores from the IQ distribution lie between the 70 and the 130. Cool. That was within two standard deviations of the mean from above. What percentage of the scores are more than two standard deviations above or below the mean? So in this instance, it's less than 70 or greater than 130. So so here we're looking at the 70 and we're also looking at the 130. So we're looking at the percentage that's above two standard deviations and below two standard deviations. So again, if you use symmetry and you think about that, you should be able to identify if you've got 95% here, is it within two standard deviations? To make the 100%, it has to be 5% that's left over on the outsides. Because it's symmetrical, it means 2.5% will be over this side, 2.5 will be over this side, which gives you the 5%. Whether you remember it that way, or whether you have this sort of diagram in your head, knowing, okay, well that's 2.35 and the 0.15, which is the 2.5 and the 2.5 there. Either way, you're going to get the same sort of thing there. Alrighty, so now that we know and we've looked at that, we can actually say that 2.5% are going to be below 70 and 2.5% are going to be above 130. Again, another way of describing this is saying if you got a score that was greater than 130 on that test, you would be in the top 2.5% of the group. Cool. Next thing to have a chat about. Oh, this is cool. This is standardized values. Yep. Now, Again, another way we can talk about standardized values is they're often referred to as standardized scores or Z values or Z scores. And essentially what happens is to work out this standardized score is we get the data value and we take away the mean and then we divide it by the standard deviation. Um, the notation for this here, or the symbols, is as follows. The z-score is equal to the data value, x, take away the mean, divided by the standard deviation. When you get this standard score, it's either going to be a positive value or it's going to be a negative value. If you get a positive z-score or z value, that's going to say, or that means that the data value is going to be above the mean. If you get a negative z score or negative z value, it means that data value is going to be below the mean. And they've got the example here. If you had an IQ score of 90 and it lies below the mean, it has a standardized value of, and we can see here you got 90, take away the 100, which is the mean, divided by the standard deviation, we get a negative z score, which, as we said, is below the mean. Now, the other thing that you need to know is essentially the z score describes how many standard deviations above or below the mean the value is going to be. And so, if you got a z score that was 1, what that means is one standard deviation above the mean score. Alrighty, I wish you all the best with this exercise. Take care for now. Bye.